Okay, welcome in everyone. Today we are looking at valid palindrome. This is, what section are we in now? This section is two-pointer? Yeah. So we are looking at two-pointer content now. We're done with arrays and hashing. Two-pointer is exactly what it sounds like. It means you use two pointers. And often we are going to be tracking things like elements in an array or maybe characters in a string. And so if you're familiar with languages that are a little bit lower level, like C++ or C, you may be familiar with pointers as literally referring to a place in memory. They've got an address associated with them and things like that. The idea of a pointer doesn't necessarily have to indicate a memory address, and in this case, the problem, as we'll see, is more about tracking indexes or indices of a string. But yeah, we'll talk more about what makes this two-pointer and what two-pointer is at our next GBM. So anyways, let's take a look at the problem. Valid palindrome says, given a string S, we want to return true if that string actually is a palindrome, and otherwise we'll return false. And in case you don't know what it is, a palindrome is a string that reads the same forward and backwards, and they specify here that it's case insensitive and also ignores all non-alphanumeric characters. So capital A through Z, lowercase a through Z, and the numbers 0 through 9. Okay, so if you didn't know what a palindrome is, that's what it is, and they give us some qualifications on how exactly to treat that in code. So we'll ignore... I'm going to pretend I didn't read that. We're going to ignore spaces, we're going to ignore punctuation, and so on and so forth. Okay, so for example, the first sample they give us is, was it a car or a cat I saw? Actually, it's being covered by the copy thing there. Okay, and the output is true because if you read this forward and backwards, the letters match up with each other. So we'll do this manually in a sec, but hopefully it's clear what we mean by palindrome here. And then they even clarify for us, hey, let's go ahead and cut out all the spaces, and also lowercaseify kind of all the characters here. Okay, next one they give us is tab a cat, which is not a palindrome because you can see as we trace it towards the middle, the T's on the ends match up, the A's second from the end match up, and then this B doesn't match up with that C, so it is not a palindrome. Some constraints they give us, again, not a huge deal to us here, but the length of the string will be between 1 and 1,000. And then the string itself is made up only of printable ASCII characters. We have already been told that we'll only care about these kinds of things anyways, but just another level of assurance. It's always going to be things that we can read and manageable characters. Okay, so this is an easy problem. Again, we've sort of started a new section here, so it's fairly straightforward to understand. If you don't quite see how palindromes work, maybe work a couple out by hand because they're quite easy, which we'll actually do right now. Oh, this actually is. Okay. No, that's not correct. I was like, I don't think that's what... Oh. Great. Okay. This is really what we're working with here. Okay, so let's do an example here. Let's go with the first one that I threw into the chat earlier, Taco Cat. Famously a palindrome. So we'll write this all out the manual way, both in the diagram and in the code, and then we'll go back and talk about some code shortcuts we can write, and just ways to make this a little bit elegant and a little bit cleaner. So when we talk about the two-pointer approach, in this case, our pointers are the indexes at the front and the back of the string. And basically all we need to do is confirm whether or not these two match each other. If they don't match, we can actually exit immediately, or we can stop trying to figure out if it's a palindrome or not, because if we ever have mismatches, it's overall not a palindrome, right? So obviously T and T are the same. Now we've just got to move each of these in by 1. A and A are the same. Move these in by 1. C and C are the same. And now at this point, this is kind of interesting. We've been moving everything in by 1. The next time we do this, the left pointer is going to move in by 1. But the right pointer isn't going to move in by 1, or that's not where it's going to stop, because the next character over is an empty space, which we want to ignore. And we'll keep moving it over till here. At this point, we can stop. So if the pointers are ever equal to each other, we can stop. Because obviously a letter is the same as itself. There's a couple ways we can kind of capture the moment that we know that we're done seeing if it's a palindrome, which we'll talk about in a sec. But in this case, we know we're done because O is the same as O. And past this point, there's no need to keep checking because we've already checked these just with the pointers in the opposite places. So this is an example of a palindrome that's got an odd number of letters, which means that in the middle, the pointers actually land on each other. It's also possible to have a palindrome with an even number of letters, like, I shouldn't do this, but boob is in fact a palindrome. And if we do this again with this string, we can do the same process as before. So B is the same as B, O is the same as O. And actually, as soon as these cross paths, so they'll never land in the same place, but they can cross paths like this. This is another moment that we know that we're done assessing whether or not it's a palindrome. So whether the length is odd or even will determine if we, can stop when they're in the same place or when they've passed each other. We can also just say, hey, when either one of these things happen, you can go ahead and stop. So we'll do this manually. We'll use some inbuilt functions to make it quite simple and easy, and then we'll go in and dissect how we can manually do a lot of these processes. But hopefully that explanation is pretty straightforward. This is not an especially complex problem to understand, so let's tackle some of the code here. Let me actually split view this so that we can refer to the diagram too. All right, so we'll do this the classic two-pointer way to start with, and I'm going to literally call these two pointers left and right. The left pointer is going to start at 0. So again, this is just the index that we're referring to. And the right pointer, we'll want it to point at the very end of the string. So when we start, it'll be at whatever the length of S is minus 1. So if it's a 5-character string, then the last index is going to be 4. So we'll start it there. Okay, and then to capture this middle condition as far as how long we need to loop for, we can say something like while left is less than... Well, okay, here's the options. We could say while left is less than or equal to right, which means we'll keep assessing even if they are equal to each other. Now, we don't really have to do that because if they are in the same place, we are guaranteed that those two characters are the same as each other, right? So it doesn't really matter if we do this or not, but if we leave it as less than, we can we can not have to duplicate or run that one extra loop. Not a huge deal, it's one loop. It's not going to really affect the runtime, but this kind of captures that we don't need to compare a letter against itself. Okay, so while the left pointer and the right pointer are actually on the left and on the right, so as soon as they cross each other or they're equal to each other, we can stop evaluating. We'll do this. We'll say if the character at the left index, and there's a couple ways we can do this. We could say if it's the same as the character on the right index, then we can just keep going. And we would use the continue keyword here. Now, rather than phrasing it this way, though, here's the other option. So this one says, if they're the same characters, continue. The other way we can phrase this is if they are different characters from each other, then we can just say immediately, hey, it's not a palindrome, right? This is probably the preferred way because we still need to capture the failure condition here. So if we did it this way, we'd have to say otherwise return false. So we can instead use this pattern that we might call early exit or early failure to say they're different characters. The string is chopped. It's not a palindrome. We can go ahead and return false. Okay. Okay, so we'll continue doing this as long as the two pointers stay on their respective sides. As soon as they cross, we're done. And if we get through the entire section on the left and the entire section on the right and we never saw any mismatches, then we can go ahead and return true. Now, actually, I am realizing a couple things. I said a bunch of stuff about what I thought was supposed to happen, and I didn't code it. So here's what else we're missing. Assuming we didn't return false, we also need to move left in by 1. And we need to move right in by 1. But that's not even true because we aren't always going to move them in by 1. We want to move them to the next alphanumeric character, right? Okay, so here's how we can do that. Instead of just moving over by 1, we can say, hey, actually keep doing this as long as we don't have an alphanumeric character. There's actually a function in Python that does this for us. And I know that it's isAlnum, but I have forgotten the exact syntax for it. So let's hope that it's this. I know that it's weird. It's either like isAlnum and then we put sleft inside, or it's sleft.isAlnum. Anybody remember off the top of their head? I will look it up if not. Pretty sure it's this. Well, you know what? We're just going to try it. If it's wrong, I'll look it up. This is my first time. Google it. Show us your... Okay. Yeah, it does. So this... you guys are crazy. So isAlnum is going to determine whether or not we're basically in the range that was described earlier, capital A through Z, lowercase a through Z, or the digits. Okay, so as long as... well, okay, hold on. Let me think about this. Oh, that's not what I wanted. We actually do want to move it over by 1 regardless, right? Because if we just purely put that condition, we're never gonna move because we're looking at a letter to begin with, right? So we'll move it over by 1, and then if you're not looking at an alphanumeric character, keep moving it over by 1. Basically, is what we're saying. Okay, and then we'll do the same thing here. We'll move right in by 1, and then as long as right is not... Oh, and you know what? I'm just realizing I said not, and I didn't type not. So if you're not looking at an alphanumeric character, keep moving. Okay, so we start these on the ends. As long as they stay on their respective sides, keep doing this. If you don't have a match, you know it's not a palindrome. And then you can move left and right in by 1, and maybe further than that if you don't have an alphanumeric character. Okay, let's see what this does for us. I might have messed something up. Oh. Whoop. Yeah, you all didn't see that. That's not real. Oh, and it's still wrong. What did I do wrong? Oh, you know what? It's totally possible that the first thing that we start with is not alphanumeric either. So here's what we'll do is we could do this at the beginning. Oh, hold on. Yeah, we might have to reorder this a little bit. So the core issue is that the right pointer starts at a question mark, which is obviously not what we want. Could we like... I'm thinking of like what's the most elegant way that we could handle this. We could just pre-treat it and like guarantee that it starts at an unknown place. But let me think. Yeah, actually this is probably better. So the way that the logic is set up right now, we say, hey, go ahead and do it after you've done the first evaluation. And we also say move it over by 1 and then start doing your checking. Instead, what we could do is we could do this treatment part at the beginning. So like make sure you're looking at something alphanumeric to begin with for both of these. And then at the end, we can just move them in by 1 because that's how we get to the next iteration, right? So this way we know that when we start, we'll have something alphanumeric for both of them. And then we move them inward by 1 to make sure we're not looking at the same thing we were just looking at a second ago. And when we start the next loop, then we can do the same like sanitizing right here. Okay, this way we don't have to repeat our logic either. It just kind of falls together nicely. Okay, let's see if that does us for... Wow, this really doesn't want me to run. Okay, let's see. Oh, I still... Guys, am I chopped? Be honest. I cannot believe I've messed this up. Okay, let's go over our logic real quick. Well, left is less than right. Okay, so if you don't have something alphanumeric here, move it over. If you don't have something alphanumeric here, move this in. Wow, and then if these are not the same as each other, return false, and then move them inward. No, is this not correct? Oh boy. Oh, you know what I forgot? You know what I forgot about? I forgot about the lowercasing. This actually fails immediately because it compares capital W against lowercase w and says you are not the same thing. So this is why our constraints are so important, and I've missed a lot of them. So here's what we really need to say here. We need to say, well, and this is sort of our option. We can say the lowercase version of this needs to be the same as the lowercase version of that. We know that we can actually lowercase these because they're both alphanumeric, right? I think digits are lowercaseable. Like, I think if we do that, it just remains the same. Okay, great. Does anybody know if that's the syntax for it? I hate to be like, who can tell me? So you can't lowercase digits, Marty. I think I just mean that in the sense that, or is it gonna throw an error if we attempt to do that? My assumption is calling lower is just gonna keep digits the same. I don't know 100% off the top of my head the behavior of that, but I think it should be fine. Okay, so let's try it out, see if it works. Yay! It did the thing I wanted it to do. Okay, so let's talk about, what time is it? Yeah, we got some time. Okay, let's talk about some other ways we can do this. First of all, I want to talk about how we can implement isAlnum without using the inbuilt version, because it's quite convenient and it's relatively simple, but you might be asked to implement this manually. So how can we define our own isAlnum? Here's what I'll do is I'll say we'll define an isAlpha function that takes a character. And we've actually used the trick a little bit before, we can use the ORD function. So we can say if ORD car, and so what this is going to do is it's going to produce the ASCII code associated with that character. And so we can say if the ASCII code for lowercase a is less than the ASCII code for the character, and that's also less than the ASCII code for z. And you know what I found out is I'm pretty sure Python allows compound inequalities like this. Let's look this up real quick. We're going to learn together. That's not what I wanted at all. You know what? I thought somebody told me this, but maybe I'm just stupid. Okay, we're just going to do this the way that works in all programming languages because of my desire to not risk it here. Okay, anyway, so if this is here, so if the character we're looking at is greater than a, and also the character we're looking at, hello, is less than z, then we're good. And then also, on the other hand, if we're dealing with the capitals, if capital A is less than the character, and the character is also less than capital Z, we can return true, and then otherwise we return false. Okay, and this early exit pattern is also quite helpful anyways, because this way we can just check one at a time. It short circuits and returns early if we meet one of the conditions, and then this is the, if we never met anything, go ahead and return false. We can also say isNum, and this is just one condition because there's no upper lower. So if 0 is less than the character, and the character is less than 9, we can return true, and then otherwise we return false. Okay, and if we want an isAlnum, and I'll say is alphanumeric just to distinguish it from the inbuilt version, we can return isAlpha or isNum. And in fact, I'll change this to isNumber because I think isNum is also an inbuilt Python thing. So, well, you know what? It should be isDigit, huh? Is isDigit the Python inbuilt version? Okay, you know what? I don't know what the naming conventions are, so don't come for me. But I'm going to say isDigit custom, just so that we know that we're not colliding with the inbuilt versions. Okay, so if it's either one of these, well, then it's alphanumeric. Yeah. Great. So here now we can say is alphanumeric. It's alphanumeric. And that should do this for. Yeah, let's give it a run and see what I messed up. All right. Oh, yeah, well, the syntax is different because we wrote our own functions here. So actually we should say, while not is alphanumeric, s left, and while not is alphanumeric, s right. Okay, let's see what else I messed up. Oh, it worked. Sweet. Okay, yeah, so that's a way you can write that manually. You know, you might be asked to do that. Oh. Yeah, well, don't yay too early because I messed something up here. Well, that is alphanumeric. Okay. Oh, well, you know what? It should be less than or equal to here, huh? Because A and Z themselves, you know, are valid. Nobody was going to correct me on this? Y'all really thought that Z? Anyways. So let's change these all to less than or equal to because it was failing on any of the letters that are listed explicitly here. Oh, so you did know it and you just didn't tell me, so you hate me. Okay, I've still messed something up. What have I messed up? Anybody? I really thought this was going to be a breeze too. I'm sure I'm missing something small, but let's take a look. Well, not is alphanumeric s left. Is this not the same exact logic? Am I crazy? A to Z, 0 to 9. Hello? Well, I guess we should figure out where this breaks, huh? Okay, wait, no, yeah, this is... Isn't this following the same logic as before, though? So I wonder why it broke. So S is dot comma here. Oh, shouldn't this have broken earlier? So we don't output anything, and I think it's because... Oh, wait, actually, no, this is strange as well. Did we submit earlier and everything worked? Symbols are not included in alphanumeric. I'm actually so intrigued by why this worked earlier. Did we submit earlier? Because if not, embarrassing. Let's take a look. Oh, guys, we fully... Oh, wait. We fully never submitted this. Okay, I think all we need here... Am I crazy? Why did I think it worked earlier? Okay, here's the problem that we're running into. This is an easy problem, by the way. Here's the problem we're running into. Sometimes this process causes the indexes to go out of bounds anyways. Okay, so how can we rewrite this? Well, not... Here's what we'll do. Wow, actually, I'm thinking about what would happen for an empty string, for example. This wouldn't be a problem because we would never hit the while because these are the same to begin with. So what we can do is we can just say, while not is alphanumeric as left. Okay, wait. We can guard this by saying if left is less than the length of s, and then if for this one, if right is greater than -1. So as long as we have a valid index for both of these, we can keep going, basically. Wow, there's probably a better way to do this, you guys. There's probably a better way to do this. Why do I feel like I've messed this up so dramatically? Okay, hold on. Let's think through if we can restructure this logic a little bit. We also need to do... Yeah, we could strip it. I'm trying to think of how to do this in like the purest way, so to speak. But I think this might do us for. Now, here's the other thing. If we get here... Okay, here, we can put another guard right here, and we can say, hey, if we got to one of these places, then we can go ahead and just say... if we're not dealing with valid indices, we can just break. Oh. And guys, I don't know how I messed this up so bad. This is a little bit embarrassing. Oh, what have I messed up? You guys, this is truly okay. This is getting bloated. I think we need to restart. We start left and right on their respective ends. Huh? Switch the true and false. What, like the return statements here? Well, no. Because this is saying if the two letters don't match, right? And if they don't, it's definitely not a palindrome. If we get through everything we need to get through, we want to return true. Okay, guys, this is getting extreme. I think we've bloated this code too much. So if we encounter something non-alphanumeric, we move left over by 1. Oh, God, this not. Guys, there's so many sloppy mistakes I made today, and it's embarrassing because I think the overall description was actually still great. Yeah, that was all I was missing. I just kept the not in a weird place. No nuke needed. I just made a billion sloppy mistakes. So if you're watching this in the future, I'm so sorry. If you're watching this in the present, thanks for helping me. Okay, so that's one way we can write our own manual. Is alpha, is digit, is alphanumeric. And then we have some guards here. Let's just talk about, because I'm a little bit over time here already, but let's talk about one last approach that is, I think, a little bit nicer. We can say... Well, any questions as I nuke this? When are you posting the recordings? We ran into a limit on how many recordings we could post at once, and I have not gotten back to it since then, but we should have more posted. I'll post them tonight. You have my word. Yes, on YouTube. YouTube only lets you like upload so many videos at once. Yeah. Anyways, not something we need to discuss right now. But let's talk about one other way we can handle this, because some of you mentioned maybe we should just try and remove all the non-alphanumeric characters, which I think is a great idea. How exactly can we do that? Well, let me think about it, because actually I hadn't really considered it. Maybe we could say something like sanitized string equals, I wonder if you can, well, here's how we probably have to do it. We'll convert the string to a list of characters, and then we'll join those characters back into an array. But now that I think about it, we don't need to do that because we can just work with the array from there. Okay, so I'm going to say sanitized string list is, I'll type this and then I'll dissect it. And again, we can write our own isalnum here. So this says go ahead and make a list, and that list should consist of all the characters in S as long as that list, or as long as that character is alphanumeric, right? And then we can just say return whether or not S is the same as, and I believe this is the notation we're looking for, reversed S. And this is actually the same, oh, you know what? Nope. I just realized we need to compare these to each other. So we'll join together that list. So if the original string is the same as the reversed string, ooh, nope. Because we have to deal with the lowering as well. Wow, there's so many things we can do here. So since we have to deal with the lowering anyways, here's what we'll do. We'll say this is the forward version. Oh, you know what? I don't know why I'm even comparing it to the original string. There's so many things. Okay, lowercaseify the character as long as it's alphanumeric. This is the forward list. And then we can just compare the forward list to the backwards list, right? So tell me whether or not sanitized string list is the same as the reversed version of sanitized string list. And there's a million other ways we could do this as well. We could just iterate through the string itself and remove things. Again, we don't really want to do string manipulation when we can help it because Python strings are immutable. So instead, if you went through and chopped out all of the non-alphanumerics as you went, you would keep producing a whole new string, a whole new string, a whole new string every time you chopped, right? So this is a little bit better because it lets us just deal with characters in a list, which are small and easy to deal with. And then we can return whether or not the forward list is the same as the backwards list. Let's just make sure the syntax is all right here. Oh man, well. What? Okay, my reversing stuff might be wrong here. Let's see what these are. Oh, they're both empty lists. Hello. Oh, this is supposed to be character. Man, I'm just full of sloppy mistakes today. Let's just make sure this works. Great. Okay, so as you can see, this produces the original string and then also the backwards version of it, but with no spaces. And it also eliminates the question mark at the end. It eliminates all the punctuation, and it lowercaseifies everything. So I'm gonna get rid of the prints because it's really just 2 lines here. And yay, the submit worked. So this is probably the solution I'd be going with. Again, we would manually implement the alnum. The one weakness of this, we have to do the whole list even if the failure is quite early, so we lose out on the early exit. But it works quite well. It's quite elegant. It's easy to understand. And again, sometimes that is more desirable. So, great. Any questions at all here other than the billion mistakes that I made that hopefully have been clarified now? Great. We'll call it there, y'all. Have a good night. And we'll be back at it again for a threesome tomorrow. So definitely hop in for that. It's going to be juicy and delicious. Okay, good night, y'all.